All right, so a little review, continuity. What does it mean to be continuous?
You can't lift up your pen.
Can't lift up your pencil, so that's the intuitive definition, but we also had a kind of an algebraic definition. And the algebraic definition basically says the limit as x approaches a of f of x equals f of a, and there were actually two more parts. One part says the limit exists, the other part says f of a exists. The equals, I mean, they got to exist, otherwise you can't write equals. So I said before, you can summarize that three-part thing into this one part. Now that's continuity at a point. To be continuous on an interval, that's going to be true for every single point in the interval. All right, and then we played around a lot, and pretty much the only time you have problems with continuity are undefined places. Okay, so anywhere a function might be undefined, and undefined happens in a lot of ways. Dividing by zero is one of them. That's the most common way we have problems. But it could be something like a zero divided by zero, which is indeterminate.
Would it be like taking the square root of a negative number?
If we're just dealing with real numbers, yeah, negative numbers are going to be a problem. And so that's going to be with square roots and with logarithms. Yeah, we didn't get into logarithms. I talked a little about square roots. And with square roots, really, the only thing you have to be worried about is you want that x to be greater than or equal to zero. With a logarithm, you have to be strictly greater than zero for a logarithm because of the way they're related to exponents. And as far as the greater than or equal to zero here, it just means at zero, you only have a one-sided limit, not a two-sided limit. And this up here implies a two-sided limit. So this function here is a rational function, which means all I have to do is worry about the denominator. So let's see, determine whether this function is continuous at 7. Well, at 7, what do I get?
0.
0 over 0, which does not exist.
But
Okay.
it's an algebra.
Well, let's look at the definition of continuity, though. What does the definition of continuity say? It says the limit has to equal the function value. Do we have a function value? No. So right away, we can say, without even doing anything else, we can say this is not continuous at 7. That's it. Not continuous at 7. Oops, that's supposed to be 7. Since f of 7 does not exist. Done. Didn't need to take it any further because all this asked, it didn't say what is the limit. I mean, we could find that and say the limit isn't equal to the function value, but we're done at the function value doesn't exist. You could go further if you wanted to, but again, this is enough right there. Enough. Now we could go further and say, but the limit as x approaches 7 of x squared minus 49 over 7 is equal to the limit as x approaches 7 of x minus 7 times x plus 7 over x minus 7, whack, whack, which equals the limit as x goes to 7 of x plus 7, which equals 14, but still not equal to f of 7. Or I guess we called it r here, sorry. R. But that's more work than I need to do. Yeah. Yeah. So if you look at something and say, oh, the function doesn't exist there, not continuous, or you say, oh, the limit doesn't exist there, not continuous. Sometimes you have to go as far as showing that they're not equal. Okay, this one is a little bit more work. So eraser, get rid of that mark. Here, so I'm going to let you think about this for a minute. For what values of x is g of x continuous? The other one asked when we were discontinuous, this asks when we're continuous. So just think about it for a minute, write something down. And we'll go over it.
No, it can be -2 or this is -0.
That's a great place to start, yeah. So right away I could say, hey, if x equals -2, then g of -2 is going to be -7/0, which does not exist. And that's the only value that makes the denominator 0.
So would it be like every other number besides -2?
Exactly, yeah. Every other number but -2, and there's a couple ways to state that. One way is to state any real number except -2, we're continuous. So this is the only value that makes the denominator 0. So g of x is continuous for all real numbers except -2. So variations on that are awesome. That's the most common answer I get for a question like that. I'll state another way we might go about it. Somebody mentioned limit laws. So we have a limit law that says the limit, oops, extra line there, as x approaches a of f of x over g of x exists if both numerator and denominator limits exist, and limit as x goes to a of g of x is not 0. A couple ways you can write that. That justifies what we said earlier too. Okay. So for this function, I could write something like the limit as x goes to -2 of x minus 5 exists for all numbers. Limit as x goes to -2 of x plus 2 exists for all numbers. But oh, sorry, I got tired away there. This is about any number, so that should be an a there and an a here. But the limit as x approaches -2 of x minus plus 2 is 0. So g of x is not continuous at -2. But continuous everywhere else. And I've known some math teachers I took classes from that say you shouldn't start with it exists, it's true for all real numbers and then give the exception. They say no, you should give the exception first and say it's good for everything else. So I've had some professors that say this is the better answer. The other one's fine for me too. Because it is a common way we say things. Okay, so important thing about continuity. is again this right here. That's gonna be true for continuity. If either side is not, or they don't equal, not continuous.